You see this here, we have a lot of openings here, we have this, then we have opening here, opening here. Somebody has to take all the trouble of fabricating or laying out the front panel. So, again I keep telling you why it was important for us to make the cardboard simulated model is that we need to lay out a proper front panel. If you remember first slide, I showed you a power monitoring box that had the same thing here, that had this thing except that it was on the right side, and then there were no keys were on another side. So, you see here we are in a nice very comfortable this thing. You see here all this peculiar notching and all, what even looks a very simple thing, you have a 45-degree cut here, you have seen this. If we were to have like that slide what I have shown here, maybe we needs to, we need to make something like this and then give a 45-degree notch, so that it, sir, if you can kindly show me this. So, I have my box earlier, you see here we have a 45-degree cut here. So, when you spread it out you have a beautiful 90-degree notch, and while sometimes it is okay, this corner is very unsightly, it does not come out well, that is how they give all the other things. So, maybe it is about time I showed you these pictures. A fully laid out with all tabs is probably going to look like this. This tab goes and attaches there, this tab attaches here, and then you see here there is some small projection here, and this is a much bigger piece, this I have shown you already, and you see this how these parts look like. That notch what I was talking you about, you watch this notch here, this is the same part, they have just turned it over and showed it here. Why I am showing you things which are available is, it is a classical, do you learn the technology and look for an application for it, or you find the application or develop the technology. So, in this case the sheet metal has been around for quite some time, probably from the Iron Age when people were using wrought iron. So, it keeps going, absolutely no issue about it. Now, coming back to our we have come to this beautiful what do you call drawing related to all this funny notches and all that. I will remove and then try to fare it up. Basically it is okay, and here you will notice one of the very important rules when you are working with sheet metal. All operations have to be done when it is in the flat condition. You just cannot, once the what do you call the bending or the forming is over, if you attempt to do any further operations except some specialty things, the chances are you will lose the dimensions. So, in this case most likely these operations, these holes have to be done, okay. These holes may have to be transferred here, alternatively you make these holes and transfer them there, or if you are in mass production and you have a fixture to make all this, make them. And in case the front panel has any openings, including that power thing here, and then maybe a keypad, you make everything here and think up front. The issue is think everything up front. This is where that making a model will help. So, all of us have seen the characteristic PC keys like this. Now, we have got used to it. This generally means up, this means down, this means left, and this means, I am sorry, that means right, and this means left. Well, it looks fine. There is no reason why things need to be here like this. This is where no little element of your creativity helps. Why not make them this way? More friendly. So, we have up, right, left and down. As arrow key is meant to work with a gimbal movement and what do you call a joystick, probably they work okay, reasonably well. Again, you still have that problem of can we make it fast and slow, then you work with two-handed operation, or do you have some small thing here in the center which operate everything. Whatever decision you take, two options need to be considered here. One is, do you reflect all those openings here? Do you reflect all the openings here, or alternatively is it a small printed wiring board which goes and sits on top of it? In that case, no, probably you will have a big opening here and no more of these small slots. You have a big PCB printed circuit board here, and that may require some mounting holes. Probably you just need one mounting hole here and one mounting hole. This is for us, enough for us, and then the whole thing is covered by a sheet on the top which will make it invisible. And in case you wanted it as a lighted panel, it is possible for us to work on all these things. I will see if I can locate the slide which I was trying to show you. You see here in the corner something else has been played with a little. You see here, this is characteristically what we do. This is what I was trying to draw and show for you. So, we have a front panel here which is inclined, and then you have the keys, and then there is an overlay sheet here, and then you see here we can even have displays. We can have LEDs at the back, we can have grouped controls, same thing here at the bottom. So, we have a big this thing, a portable what do you call inverter for CFLs. Why I picked it up is boxy saying you can easily. So, even today a large number of items continue to get made by this type of sheet metal work. We see a small detail here in the corner. What I was talking to you is there, how things overlapped each other, and then you have a handle, and now you take a decision whether you see these 4 mounting screws which is for the top cover. You have a top and bottom cover, and then you have a small front panel. Advantage of such a device is you can take things out and then service them. Now we come to the important, the very first question, if you remember. Very first question is, on what way do we decide on this? You understood, no? Decisions. So, if it were one of those what you call inverters or housing things, they continue to be boxy. It is a production prototype you are making, and they continue to be mass produced. Advantage being still mild steel is cheap, very cheap. So, it is for you to take a call on all these whatever has been made here, and then see what best you decide on how to produce a thing. And then my own call is, if you are a small entrepreneur, instead of going for the world design, if you concentrate on what is it that you would like to make and present. It is very much possible for you to make something, learn a little about the sheet metal work, and then try to do various drawings and get ourselves into this, and then try to make a box like this, which I feel is a very simple and easy way to go. Now, I will take you back to a few more slides and show you what things can be done. So, I think I have shown you all this. These are all small some ultrasonic welding equipment, and this is what you will probably you see this equipment all around with you. This looks like one of the what do you call cables for your Apple, and then these are all various boxes. This is probably something related to a biomedical equipment. You see here, this is a normal monitor. So, this monitor has been mounted in this thing which I do not know, yeah, it is probably part of some ECG or something. So, they try to make, this is partly made out of sheet metal and all that. Now, we have this ubiquitous amplifiers and DJ equipment. Invariably all this equipment, no, they come with massive power and all that rugged, and this is probably 20 or 30 years old and still it goes and used in harsh environments. And you see here we have a beauty. Only thing which I thought I will point out is that the side panel is itself an aluminum heat sink, and then on the top they have given some openings, and on the top of this you have some DVD or some VCD player, and they are enduring. Any of these designs, they last forever. Okay. This is an old very well known telephone form. This has not died out, and you find it more convenient, and then there are people who use it, and then you have this modem. What could be a very ordinary what you call table thing, based on the semiotics. Now, you see they have added a few things here. I am not sure what is the purpose of it, but I know it makes it desirable, and this is a purely technical thing. It is a what you call conducted Emi filter, and because of the technical what you call nature of it, it has to be made out of a single piece. Whole thing is made out of a drip down can. I have no comments about the material, but I expect it is a special material. And while this is purely for a technical reason, this is purely technical, here it is partly aesthetics. Aesthetic reason we have, this is ergo plus aesthetic. This is more as a what do you call sales this thing, that the things are made to be made a little softer. If you are to make something like this, chances are people won't want it. If you were to keep it on your table or somewhere in a visible place, obviously things like this continue to help. Now, we come to several equipment, several things which are often one off. So, this is from Knorr Dakoba's our studio. Equipment is a studio, we have much smaller version of it. If you see here, part of this furniture and all is all assembled, but the other details often you end up with small boxes. I expect this is probably a mouse or something, and then you have a mounting rail and all these things. They are made with structural elements which are taken from the technical furniture field. So, I will just go down to the to the end of these slides and see where we go. Yeah. Seen this? Now, we come to what I was telling you about a job shop. In the case of a job shop, things like this, I do not know whether it is a riveting machine or a drill or something, and then we have several things, and what you call, in a small workshop they are all available, but conditional to your being able to imagine a proper product and then make sketches, make a prototype which you can demonstrate. It can be in the form of a cardboard model or some sheet metal thing, And if you now give it to these what do you call job shop people, they will make very beautiful equipment which will keep going more and more and more. You will never end up with a failure. You continue to have equipments which will work 100% all the time. So, over here it is lunchtime, and then I will stop here. Before going, I thought I will show you a beautiful cake box. This is probably one of the best cake box I had it. Open it, opens, beautiful cake box. Of course, this is not a what you call cake cover, but then we had used it as that. You see here the way they have made, box has been made such that you can even have a frosted pack. So, you can have an ice cream cake in it, and then as you open it, it is a wonder to me to see who has imagined such a beautiful getting better and better and better. You see here, I have such a beautiful box. Whole thing is made out of a single sheet of paper, nothing is wasted. See here, every corner, every bit of material has been used. A little bit of overlap and what is lost probably is used as packing somewhere. So, I have a beautiful huge cake box here. Sheet metal as yet has not come to this stage, but is about as much there. You have seen that, no? Sadly, I cannot give you the food because I have already finished it. Even if you take routine things like, I think I should avoid the trade name. This one is a throwaway box. Well, throwaway does not necessarily mean it is a waste, it can be recycled easily. This part of the top portion is made out of thermoforming. So, this can be shredded and used, and then this is classical cardboard. So, you can do some craft out of it, or probably it can be recycled without any problem. The same concept is slowly entering into our electronics field. Any of our enclosures and all that what we make, it is expected that we can reuse the materials. One of the easiest way of reusing the materials is to use standard recyclable materials and as much as possible make them detachable. If something is stuck together and laminated, polylaminated materials cannot be recycled. But if they are made different materials and they can easily be separated, it is very easy to get them reworked again. So, you can supply them all, send them back to the factory, and they deal with all that, and overall the environmental load is reduced severely. In the next class, I will see if I can take you to the workshop and then try to show you how these sheet metal work is performed. Okay. So, what the sheet metal in this case, as I have showed you already, I have two sheets, both of them are about the same size, and then it is all marked, marking you can't see here. And then after you finish say bending it, you will notice that because of the variation in thickness, both these will not give the same job outside. The limbs may be slightly different, and this is part of it. As an equipment designer, you need to be familiar with these items, and this particular course has been run in this department for the last I think it has been running since 75, that will make it 40 years. So, people have benefited by it. I expect that in the next succeeding class, I will see if I can show you how to mark out a sheet, how to make this thing. Now, if my video people can kindly take me back to this what you call PPT. See, as I said, we make a honest attempt in trying to make a development drawing. Okay. Why do we need to have a development drawing? We need to have a development drawing because after bending it should form the original dimensions what we intended. And why do we need to make it? Why does an electronic engineer need to make it? Yes, finally you do not need to make it, but you need to work with these people on how well your final production is going to be. And the reality is both sheet metal work, standard enclosures which I have shown you in the first or second slide, and thirdly rapid prototyping are real. Now if you have one person in the team who can help you with these things, you can the teamwork can help you with this, saying this, we need to take a decision about it, and then any decisions taken at the highest level, okay, decisions taken at the highest level have far reaching impacts down. So if you work, think about it a little here and then come and implement those things here, you will save a lot of time, money and effort. And contrary to popular conception that it takes time, it is the other way. In the longest run cycle to the market, probably the least cost and the least time are spent in it. And the moment you know that the downstream, these are downstream decisions, and then you incorporate them up in your design at the highest level, it will become routine for you. Now it is easier for you to make things which are quick to market and easy to produce and economical, and finally recyclable. So thank you for today's lecture, and then hopefully when we meet again I will take you to the workshop and then see how we go about making a small unit. So there are again two issues for it. Do we make a sample unit based on a a product or not? It is both. So it is fine to learn. You make a small exercise, learn, then you have a concept in mind, and eventually when you implement all this and make it, things work. Because of me working with computers and all that, and using digitizer, I have spoiled my capacity to draw straight lines. I can't draw a straight line. It is just sad. It does not mean I am kinky or anything. It is just that the manual dexterity has come down. Not long ago, only about 30 years back, we had a drafter, and then we had to make everything proper, and there is no simple way of modifying it. Now that we have the digital tools are available, it is possible for us to make beautiful repeatable structures without too much of effort. So after learning a little about the workshop practice, and also maybe learning a little about what can be done in using plastics, probably I will introduce you to some sort of a computer aided drafting. So there are three things about it. One is simple drafting. You understand, no? Simple drafting, it will take a drawing and sort of make sure that lines are horizontal and vertical the same way as a drafter does, and then design with assembly. Once you make things in 3D, you can make things fit together, share dimensions and all that. And thirdly, the analytical part of it. Analytical right now, that's a different field, and I am sure other these things, other people can help you better. At the conceptual level, if you have things a little in the background, probably once you make some idea or one design concept, later on taking it and optimizing it will be slightly easier. It comes to an old egg and chicken question, saying how do we select a particular option? Not yet solved. One way is work through all the details of each option and then decide which option is good. So, that is from the optimization point of view, either it is stress analysis or it is about materials or fabrication. Another is because we have accumulated lot of these things as gut feelings, we can ask somebody who is familiar with it saying what do you think which works, but then people come back to this saying, if a customer were asked once upon a time when the motor car has not been invented, what would you want in your new carriage? So, they know, no, it is very smelly, is there a way of getting rid of all that smell, and can we be clean? I think in the very first or second lecture I told you the allegorical representation of the horsepower has not gone. I have more horses, but things have changed a lot, except as I told you a few of the things. One of them is the horse carriage suspension continues to be made, very heavy things, no. Only maybe around 10 years back, even when your railway rolling stock, they have changed over from the leaf springs to other what do you call helical springs, and later on to rubber elastomer mounts. So, the elements of, and then the analytical part. So, if you see the original steam engine, it had that Watt's governor. So, parallelly on how to control or have the mechanical thing, and how to do controlling these things, including what is a loop, what is loop gain, how do you amplify, and what is the error signal, what is PID, they also have been developed parallelly. So, now these days you do not need to worry too much about it. If you want to give a small advance what you call injection in your diesel engine or anything, not a big deal anymore. A multi-jet engine is understood. I can't make one, but it is understood. So, but if you see an old what do you call locomotive diesel, I mean the steam locomotive, the actual part which produces the power is just a small cylinder. So, big engine, maybe the cylinder is so much, but the locomotive is so big. And then just to give a small advance to the steam, all that linkages were required, so that steam can be injected a little in advance. Now, thanks to electronics and all that, it is very easy for us to work with all these things. So, thank you. Let us meet again.